Hello, I am Max Eastwood, and I joined the ERBE CDT programme in autumn 2020. Before joining ERBE, I studied architecture and environmental design, followed by a Masters in Architecture, both at the University of Nottingham. I also spent a couple of years in the industry, working on a range of projects across multiple sectors, including healthcare, education, and residential. I joined ERBE because I wanted to pursue my interest in improving the efficiency of dwellings. My experiences in the industry had showed that this is full of challenges. I wanted to reduce the emissions of the existing housing stock by resolving some of these issues. My first year has allowed me to broaden knowledge, develop skills, put my work into context, whilst designing my own research project. Working alongside people from a range of backgrounds with a great diversity in research topics has been a particular highlight so far. My research project aims to assess whether the onboard monitoring of a dwelling's fabric thermal performance can provide retrofit quality assurance. There is a well-reported gap between the designed and as-built thermal performance of dwellings. This is seen in new build and in retrofit. One commonly attributed factor is build quality, such as poorly installed insulation. By accurately measuring the as-built performance of dwellings, this can be compared to design intent, demonstrating construction quality. Existing methods of doing this are intrusive and expensive, often requiring houses to be unoccupied for multiple weeks. Onboard monitoring uses inobtrusive sensors such as the smart meters already in many UK homes to measure the performance of dwellings whilst they're still in use. This has the potential to allow for testing before and after dwelling retrofit, ensuring build quality and demonstrating that the work provides the desired reduction in energy demand. In my research, I want to identify a suitable data analysis method for estimating the heat transfer coefficient of an occupied dwelling using onboard monitor data. I aim to understand and quantify the sources of uncertainty in estimating the HDC of dwellings. I also want to understand and quantify the gap in the measured and predicted HDC of retrofitted dwellings. I have just completed a pilot study in which I have successfully characterised the HDC of 4 out of 5 dwellings to within 10% of a given value. This used existing datasets including smart meter and local weather data. The Severe method showed the greatest accuracy in this study so far, with a mean deviation of just 9.4%. A sensitivity analysis has shown that the average method can accurately derive the HDC using just 5 days of data. However, the pilot study has raised some challenges in this research. Each of the methods used has multiple sources of uncertainty, including the estimation of solar gains. The estimation of unmetered gains, in particular occupancy-induced gains, are shown to be prone to uncertainty. These include metabolic gains from the occupants themselves, and the heat loss when they open windows. Some such gains have been seen to cancel each other out in this study. Further work will investigate these uncertainties in greater detail. Over the coming months, I'll continue investigating my findings of my pilot study, including further sensitivity analysis to understand the uncertainties in the methods. I'll conduct case studies using the match pair test houses. This will allow me to investigate inter-dwelling heat transfer and to impose a controlled, simulated occupancy. The current plan of work involves field trials which will take place in winter 2022. For these, I might need to collaborate with someone working with large data sets of dwellings and undergoing retrofit, which might include an industrial partner. I am also looking to collaborate with anyone researching heat transfer, the estimation of internal gains such as solar and occupancy, as well as anyone whose work involves construction quality and defect detection. Thank you for watching. Please don't hesitate to get in touch with any questions about my work.